to spend a little time to introduce our first speaker of this afternoon. He himself is a reputable entrepreneur for several Silicon Valley startups. And for the past few years, he has also held executive positions for many large semiconductor companies. Today, he's going to give us a speech on IoT and Taiwan industry initiatives. Ladies and gentlemen, our speaker, Dr. Peter Hsieh. Doctor, please.
Thank you. Welcome. Considering the last 2 days was Taiwan's national holiday, this is a great turnout. And for the last 2 days, I've been busy as usual and not a holiday. But today, I think I'd like to talk to you about the IoT and Taiwan industry initiatives. I think this is based on a lot of observations I've been gathering for the last 3-4 years, experience from our international and our regional partners. This is a lot of observations I think can be useful. And the things that we observe, I think not only useful for Taiwan as a region, and also for many other regions as well. So I will talk about the IoT market landscape and value chain, and then the IoT vertical industries and IoT foundation technologies, and then the Taiwan industry opportunities. Then I will talk about some of the things that ARM has been doing in the IoT space. And at the end, I will talk about an IoT investment fund that we are recently forming. In fact, this month, we are closing a venture fund to invest in Taiwan and also in any other regions where there are interesting projects. And I'll give a short summary. I've been traveling to Hsieh show January in Las Vegas, MWC in Barcelona, and CeBIT. And from these major shows, I list down all the things I've been seeing in those. And as you can see that the topics covered in those events are fairly similar. You know, voice, AI, 5G, vehicle to everything, so on and so forth. So these are the set of common interesting topics that every country, every region are looking at it. And I would say that this particular event in Computex, many global companies choose Computex to announce their latest, greatest product. Here, just yesterday, today, tomorrow, we see a lot of breakthrough products. Performance reaching never reached before, and not just 50%, but many, many times, addressing AI, addressing big data analytics, and many, many others. I think among all of this, then I will try to extract what are the foundation technologies that are required to support the future development in the IoT and in the cloud service space. So first, the IoT verticals, those are very known. Well, the point is list down the semiconductor, healthcare, automotive, robotics, so on and so forth. I think those are very known IoT verticals. Everybody knows about it. But what can you do in those spaces that are truly innovative and create big business? Okay, this again are a large number of different verticals, so I will not spend a lot of time on this. So let's look at some of the foundation technologies that are required to support all these verticals. The edge intelligence, and by that we don't mean just processor to extract a little bit of data, but something in the future, near future, that are sophisticated to create data processing and create useful data that can be passed to the cloud, okay? And I'll talk more about why this is very important. The networking, the server, the high-performance center, and the AI accelerator. I think you hear many companies talk about new product, ARM included. I think on the 29th, we talk about AI performance increase by at least 50x in the next coming 3 to 5 years. At least 50x, maybe 100x. Cloud service platform is very important. We here in Taiwan, we used to sell a lot of PCs and a lot of smartphones hardware. But in the future, it's not the horizontal huge market, it's the verticals. The volume may not be quite as big, but the value added is tremendous, okay? And how do you build this kind of cloud service platform end-to-end so that you can create this high value added service? 5G is coming, and narrowband IoT is also coming. And then automotive, everybody talk about it, robotics, drones, so on and so forth. Now, underlying all this, I think there are two foundation technology. One is the AI, and one is the big data. When you have billions of IoT devices that extract the data, and today is little data, and in the future with edge intelligence, it's huge data. And when you extract all of that, what are you going to do about it? You need to process some of those right at the spot, and some you have to transport through network, and some goes into the cloud, okay? So many companies in the world are busy acquiring companies that can do AI. And here is a list of companies that has done AI just in the last 12 months. It's a long list. And I would say that also including ARM. I didn't put down ARM, but that includes ARM also. And I use NVIDIA autonomous driving as another example for AI. I think if you went to Jason's talk yesterday, he has a 90-minute talk on AI that his company is developing. It's truly impressive. I think just on the last 12 months, he has this Drive PX, Drive PX2, and now XVIA. And XVIA he calls a supercomputer. Okay, a supercomputer with 30 teraflops of computing. So these are examples of AI chips or machines that's coming to the market now that can do a lot of AI processing. In the automotive space, there are a list of companies that does, different automotive companies that are engaging in the autonomous driving system development. Everybody would think Tesla is on the front, but actually many other companies in the space are also doing autonomous driving AIs. So the AI and the big data are two foundation technology, and given that, I want to spend a little time talk about what are the industry opportunities for Taiwan. Taiwan as a country has been in the hardware manufacturing-centric business for a long time. It's one of the most important country in the world. Semiconductor, TSMC, as you know, 10 nanometer, 7 nanometer technology, and going forward to 5 nanometer, is truly one of the greatest semiconductor companies. But there are also, Taiwan has also many other strengths, vertical strengths, in healthcare, in automotive. Maybe a lot of people doesn't know that Tesla's most important supply chains are actually in Taiwan. Okay, so in robotics and smart city and content creations and precision agriculture. So there's a lot of vertical strengths in Taiwan. But all this vertical strengths needs to engage now with these IoT technologies to to adopt the IoT technology and transform the strengths into something that they can service through the cloud. Okay, so that's something that I would talk about it later. Okay, what can we do to help Taiwan to continue this industry strength and to transform it to the cloud space? So I'll talk a little bit about the SoftBank and ARM vision about the AI and big data. This is data taken directly from our chairman's son. Okay. His view is that the internet connection point, the IoT will exceed mobile by 2018. And mobile today is growing from 7.1 billion to 8.6 billion. But the IoT will grow from 4.6 billion to 15.7 billion. And the number of IoT devices will add up to 1 trillion devices by 2035. The IoT traffic per month will grow 2,450 times, 2,500 times by 2035. That's a tremendous growth. If you compound it, it's probably more than double every year, okay, in terms of big data. And also his observation that the speech recognition rate by AI is 94.1%, better than human. And the visual recognition rate is 96.4%, also better than human. Okay. As a matter of fact, just last few weeks, you hear that Google has this Google Lens, Amazon has this Amazon Go. Those are some of this AI being applied to extend our human sense, so we can do our daily work much quickly. Okay. So when all this big data created, then you need very powerful artificial intelligence to process it. Okay. Starting from edge to the cloud. So here I have one chart that kind of shows how the data is going to flow. So So on the left-hand side is this whole bunch of IoT and the smartphones and laptop and PCs. On the right-hand side is the data center and the cloud service. In between is the access point, the edge points, the aggregation points, the core. Now, what's different from before is the network used to be at just one pipe, no flexibilities. But in the future, we see that a lot of intelligence needs to be added in the network to do computing accelerations, and to do storage. You simply do not have enough bandwidth to send the data just right through the pipe to the cloud. Just, with 2,500 times growth, there's not enough bandwidth, even with 5G or beyond. Okay. So you need to do a lot of local processing throughout the network, and even at the edge, to do that processing. And today's processing may be simple, but soon there will be very sophisticated artificial intelligence-based edge devices that will be processing this data. And once the data is processed, you'll be sending through the pipe, depending on the nature of the data either will be further processed or stored, and then send the essential data to the cloud. Now, the cloud is also underlying changes. Today, one of the big problems the data center is facing is that it's reaching the thermal limit. As you have more and more computing tasks to do, not 50% growth every year, but multiple times every year. When you already reach to that thermal limit, what can you do to accommodate all that increased computing density without increasing the power profile? That's the challenge. So I think we start hearing changes in architecture, changes in data structures to improve the computing speed. ARM was announcing 2 days ago that the AI can be increased by 50 to 100 times by a number of different ways. I think Jensen yesterday in his talked about including 5,000 CUDA cores in his chip to process this. In fact, the progress will not stop today, this year. I think next year it will be even more exciting things coming up to help solving this big data problem. So one of the things I would talk about that ARM is trying to help transforming the industry is that we are building an embedded platform from edge to cloud for companies who has a desire to do the cloud service but may not have the expertise or the time to do it. As you know, it's a very complex process. If we talk about you try to connect any device, a device maybe in the pacemaker, to a healthcare cloud, any device anywhere to any cloud, that's a hugely complex problem. So here at ARM, we try to build a platform from any device to any cloud with securities and with energy optimizations. You always spend the minimum energy required to get the job done. Okay. High performance, but adequate performance to get the job done. So that's the platform that we are building to help companies, startups, or companies that has been in the business for a long time, who has a desire to offer the product and services in the cloud space. And that's the embedded platform that we are offering. We've been working on this platform for many years. And I'm happy to tell you that this platform is now mature, has been tried out by many companies for quite a few years. And these are some of the technologies being proven across a number of devices in many different applications. Okay, so here in this slide it lists down some of the key IoT applications like automotive, like industrial, like healthcare. Those are very important industries, but by far, I mean, the whole IoT space is much bigger than this. But this is probably some of the most talked about process. I think even in healthcare, it's very exciting. I've been attending quite a few seminars with interacting with a lot of doctors. I think cancer is one of the most challenging problems. Through a lot of recent discovery, the cancer has a lot to do with immune systems. By being able to analyze our genome sequencing, observing the pattern and the change of the pattern and tracking of the pattern, you can come up with medicines and treatments that could be a lot more effective. And all of that requires a lot of big data, So one of the things that we are initiating in Taiwan is to work with hospitals and data centers to extract that data and analyze it so we can come up with effective medicine and treatment methodologies for oncology. This is the autonomous driving. I think that's a very hot space. Almost every automotive companies are working on autonomous driving. If you are not in it, you'll drop out. Okay. Automotive becomes an electronics product. If your autonomous driving is not in the front, then the company will drop out. This is a piece of complicated machinery. We are developing sensory fusion modules that can detect the vibrations, the heat, and the sound, the noise. That just like when people get sick, there's a few symptoms. when machine gets sick, you can actually detect many weeks, many months ahead of time and do something about it, as opposed to when the machine finally breaks down and you have to pay the consequence. Again, this is healthcare. There's a lot of things that can be done. I think many doctors told me that medical field is one area where a lot of machines are still pretty much in the old days. You know, RS-232 output. Nurse has to take down a lot of data by hands. I think there's a lot that can be done in the medical and healthcare field. Again, this is another medical device for colorectal detections. This is zebra's timing tracking. So this is just a lot of examples of IoT applications that ARM has been working with a number of companies. This is one smart city parking meters using the IBM blockchain technologies to collect money without paying the real money. This is another project with Uber. Okay. And this is Samsung's VR gear. So I will say a few words about the ARM IoT Fund. Taiwan is full of energy. I think if you walk around the space, we already see a lot of startup coming up. And all this startup requires capitals, require mentoring, like Hank, requires a lot of people who has been experienced in the industry to help them get started to strategize the market and sales strategies and to come up with product that can connect with the rest of the global markets. So ARM wants to come up with a venture fund and working with global international funds and local funds to help companies to get into the IoT space. So in summary, I want to summarize a few observations. The big data and AI is a foundation technology for IoT and cloud service. AI is coming here today. It's already here. It will be getting better and better, more powerful, more diversified. AI is not one type of computing. AI is many computing. We can see the CPUs, we can see the GPUs, we can see FPGAs, we can see a lot of dedicated accelerators, all integrated in one machine or in one chip. So that means the AI framework, the software architectures, the drivers, all becomes much more complicated. The data security is very important. Almost all serious applications require data securities. How do you get connected, get big data without getting hacked? There's a number of very famous hackers say every connect car can be hacked today and has been hacked. Okay, so that remains a challenge. The computing system, in my opinion, we prefer open distributed parallel processing and with dedicated accelerator to be the computing platform of choice. The reason we said open is very important is because you cannot at this point predict what kind of accelerator will be needed in the future. There are many different varieties, each serve different purposes. So if your system is closed, chances are the system cannot take advantage of the accelerator that will be coming up to the market from all sorts of vendors. The low power remains to be very important. I think in the future, computing performance will be higher and higher. There's no bound. There's no bound to that. You always ask for a given workload, what's enough of performance, not what is the absolute highest performance. because you want to be enough of performance to get the job done so you have a good user experience. And at that performance point, you want the lowest power and the smallest area because power and area does cost a lot of money. The ICT industry is going through an inflection point, and today is probably at the greatest changing point in the last 30 years. And I hope everybody enjoy this change, capture the opportunities, and do well. Thank you.
Thank you, Doctor. Thank you very much. Great talk.